Once you're on the customer side of the area, and each one of the doors, there are CCTV cameras, which are monitored 24/7 by our staff. There's one in the front of the door, there's one on the back of the door. We record these cameras and we see them constantly. And to get into the facility, you have to have an HID accepted card. If there's a change of employee status at a company, we can shut these off with a moment's notice through our knock. We open up a trouble ticket and can allow access for people in and out. The facility has a fiber termination room. The facility has a fiber termination room that has a number of carriers. The carriers come into the facility in diverse entrances. We utilize Force 10 equipment. We have carriers in here like Quest, Level 3, XO, Savvis, Time Warner. We run a BGP mix. We have our own AS. So we have peering sessions, Seattle Internet Exchange, and dark fiber for some of our customers. It's built in, again, a redundant fashion that theoretically, if one switch goes down and a customer has two feeds, one from each switch, they will not see a service interruption. And as we are carrier neutral, many of our customers have connectivity from other carriers that are directly in here. Again, Cogent, Level 3, Quest, XO, AT&T, Savvis, AboveNet, etc. The data center itself is on each floor. We have 2 floors of the building. It's 18-inch raised floor, and all of the facilities that come out to the floor through ladder rack for fiber, cable for Cat5 are delivered overhead then down into the cabinets. We have cage and cabinet configurations. Our data center here, our largest customer is 2,000 square feet on this floor. And then our smallest customer, we actually sell quarter cabinets, some 1 and 2U applications, but generally as a convenience to people for gear that they want to use as out-of-band management. It's not a commercial product for us. This is a fairly standard configuration. Cabinet, 42U, locking, power is delivered overhead, comes in, raised floor tile, cooling tiles, hot row, cold row configuration. The data center itself is an average 68 to 71 degrees depending on where and when at what time. We utilize condenser water from 3 cooling towers that are ours. The cooling towers feed the crack units. The crack units are 2-stage. We'll have a secondary system. This is the data air. That's a Liebert. The Liebert system goes out to split units on the deck to give us a 2N diversity in our cooling. The cooling utilizes 2-stage cooling. Right now it's telling us our input temperature is 73 degrees. Our output is 46. And as though you can't feel the temperature, Brady can tell you later, if we walk in a cold row, it's in the low 60s at the entrance point. It's a standard cold row environment with the cold tiles on it. Cold air comes in, hot air releases and cycles back through the crack units. This floor currently is running an ambient draw of 281 watts a foot of draw for our customers. We have some very large customers that utilize up to 23 kilowatts per rack. There's some rackable systems in here that run on DC power that are actually quite large, 52U, and they draw a lot of power. The floor itself is designed in 7 zones, so the pre-action and FM200 sit in zones. If there's an event that happens in one zone, say for example the 4 battery rooms or the different zones on the co-location floor, that event will be the only area affected. So we obviously see this alarm. We have a number of alarming companies, Guardian, Fire Chief, the fire department, our landlord, ourselves. So if there's anything in our fire room that measures this off our ATS system, our smoke detector, our laser system, our VESDA system. It'll warn us first. We can go down and address the issue. There are times in data centers with sensitive laser inputs, such as a vacuum cleaner blowing out a little bit of dust, will sensitize and set an alarm off.